just to let you know, everyone. Do you think we should start, Paul?
Yeah, why don't we go ahead? I think we have a good number here, and other people will file in. If we just get started with the introduction, we'll be in good shape and keep the time. Yeah.
Thank you. Okay, thank you everyone again for attending this session. This is our second day of this workshop. Just to let you know, all the materials, notes that we have been taking during the last session will be posted at the end of this session as well. We will prepare it and post it and let you know. So just to go to the agenda today. So today we will host two panels. The first panel will focus on the status and development plans for CAN-ASM. The moderator will be Paul Kushner, and the panelists for this session will be Vivek Aurora, Jason Cole, Jianping Li, Paul Meyers, Ivy Tan, and Neil Swart. And for the second panel, it will focus on CP4C, Science Application and Collaborative Environment, and it will be moderated by Neil Swart. And the panelists for this session will be Joe Melton, Andrew Shaw, Hansi Sin, Clint Seinen, Jack Virgin, and John Sinoka. So just as an additional note before we start, we thanks again University of Toronto students, Alexander Audet, Haruki Hirasawa, and Jack Won for acting as a reporter for this meeting. Also, we invite you to ask questions and make comments at the Google Doc posted right now in the chat. And please feel free as well to ask questions through the chat verbally. Sorry that I didn't modify this bullet point, but as long as we have the moderator giving instructions about how we will take the questions, but feel free to put it and input in the chat or in the the Google document. Reported notes, as I said before, recordings and workshop materials will be posted following the meeting. So now I will pass it over to Paul Kushner, who will explain more about the panel details and who will be moderated this panel. So I will stop sharing.
Hello, everyone. Good morning and good afternoon. Thanks, Daniela, for kicking us off. And so we're back again after a great session yesterday. I wanted to start by talking about the panel one here. And basically, I hope the discussion is pretty free flowing, but I'll give you do some formalities just to say that panel one's intention is to focus on CAN-ASM status regarding development and applications. All right, so we had some good updates on CAN-ASM. And what we've done here is kind of pair people who are working, spending most of their time on working on CAN-ASM within CCCMA with people who are actually using CAN-ASM, or are interested in using CAN-ASM from outside CCCMA. So in particular, with expertise maybe more centered in the atmosphere, we have Ivy Tan from McGill. And actually, if all the panelists could turn on their cameras if they're comfortable with that, it'd be great. Ivy Tan, actually don't see, is Ivy here? Oh, there she is. Okay, good. Ivy Tan from McGill with Jason Cole from CCCMA. We have Vivek Aurora from CCCMA and Jianping Li from University of Saskatchewan. And last but not least, Paul Myers from the University of Alberta with Neil Swart from CCCMA. So the last two, their expertise would be sort of more centered ocean carbon cycle-ish stuff, marine carbon cycle maybe, if you want to be pigeonholed. And for Jianping and Vivek, it's of course a land surface and terrestrial BGC and that kind of thing. So that's the basic idea, and I have a sort of a very general sort of set of questions just to ask you to, given the information from day one, what are the main scientific and technical opportunities related to the development, application, and analysis of CANI-SM for your own research, but also speaking as a member of a larger research community, for that community. And I've given you kind of a general time frame to consider, which is roughly the 3-year time frame of our allocation for the research platforms and portal allocation from the Digital Alliance, and that's it. So I guess I'm going to start from the atmosphere because it's our coup, right? I'll start from the atmosphere, and I thought we could just give the floor to Ivy and Jason, and then spend a few minutes, have some discussion, and but I'd like to sort of work to the land and then to the ocean in the end. That's kind of how I saw it. I hope that makes sense to everyone. Of course, questions and discussion are welcome all the way along. And sorry, one other formality is that we suggested that you don't present slides, but if you have some slides you really want to show that have some important information, of course you should feel free to share them, and just let us know. Okay. So yeah, so Ivy, Jason, do you want to kick things off with some remarks?
So Ivy, is it okay if I just go first?
Yeah.
Sure.
Just to start, I mean, I'll try my best. Yeah, so I unfortunately didn't pull up some slides, but I think just building off what I showed yesterday, I think people have a kind of a feel for the large scope of what we're trying to do currently for getting them all together. And it's kind of broad, right? So there's going to cover a lot of different things, from physical parameterizations like convection boundary layer, which we're developing and putting in the model. And then of course, expanding into aerosols and chemistry, which we have these new large packages being brought in. And I think these bring with them a lot of opportunities, because although we're putting the core parameterizations in and we're testing them scientifically ourselves to make sure they make sense and they work, but of course it always benefits having another pair of hands and eyes looking at these things and contributing, not developing the entire parameterization itself, but kind of looking at it in detail and maybe making suggestions or helping develop little parts of it or pieces of it that can really focus in on the time scale that we have. Because 3 years sounds like a long time, but when you're trying to develop a whole parameterization, it's quite challenging. But if you could take a piece of a parameterization and kind of work on that and get a detail that's improvements, or make suggestions about improvements, or show how well it does or how it could be improved, that's really good. There was some questions yesterday about configuration. It was a question in the chat yesterday, and I brought it up yesterday. So I think it's given some of the flexibility that's coming with this ISME approach, IMSI approach, it gives potentially some opportunities to look at the model and run it configured in different manners. So I mentioned yesterday, I see there might be some opportunity to revive this middle atmosphere that had a lot of power in the past when we had CMAM and CSpark and all that kind of stuff, where there was a lot of people at CCMA and at universities kind of really contributing to that. And that's of course with the chemistry, and also I would suggest without the chemistry, just even dynamics and general physical model. Just for my own interest, there was a mention yesterday from Neil Tannen about aquaplanet configurations, and I think you mentioned it, Paul. I know Phil's asked me many times in the past if this could exist. That's a personal research interest of my own that I would like to kind of push forward. And I've actually started working on it, but I just ran out of time because it wasn't the highest priority for me to work on. So I'll just kind of sell that if anybody wanted to work on that, I'd be more than keen to collaborate with somebody with that. And yeah, so there's a broader thing about looking at all the parameterizations. For my own research, I do have an interest in this climate intervention approach, kind of looking, and that's kind of coupled in with the middle atmosphere, getting that going, because that's a critical part, I think, and also having good aerosols, chemistry, etc. And it also has a lot of side benefits because it requires developing the model, continuing development and improvements, but also has a side effect that you can start looking at other interesting questions with the same developments that you're going through. So if you want to look at volcanic effects, or you want to look at large wildfire injections into the stratosphere, etc., if you had that model in place, you could look at these other interesting questions, but also have the capability of looking at climate intervention at the same time. So I think that's kind of a quick summary. I don't want to take a lot of time, but I think that's kind of what I wanted to take away from yesterday.
Yeah, that's great. Thanks. Ivy, did you want to respond or continue those comments?
Yeah, so Jason focused on applications for the middle atmosphere and climate intervention. And so I think I will talk about the applications for clouds and climate sensitivity. So yesterday, Jason gave a really nice overview of the developments of CAN-AM. And so one of them that I'm personally particularly excited about is the incorporation of the P3 scheme into the model. So this will allow for a lot more sophisticated cloud ice microphysics in the model. And I think it'll be a big improvement from what it is currently in the model. Namely, there are basically no aerosol effects on the cloud ice microphysics currently. And there's also no representation of the diffusional growth of ice crystals at the expense of liquid droplets, which has been shown to be really important for things like the cloud radiative effects, climate sensitivity, and also precipitation. And so I think that incorporating that, especially in the process of that, using the single column version of the cloud model will allow for incorporating and testing how to basically do some sensitivity tests. So we could basically incorporate effects like ice nucleation. We could test implementing more sophisticated schemes using the single column version of the model. And I think that this will, the new single column version of the model will allow for that sort of testing. So I'm looking forward to that. There's also, I heard from Jason's talk yesterday, there's the incorporation of new aerosol sources in the model as well. So in particular, based on some information I got from Knut von Seltzen, there's also some mineral dust emissions in the Arctic that will also be parameterized in the model. So that's another potential application direction that can be improved in the CAN-AM model. Jason has also been working on developing Green's functions for the CAN-AM model. And I think based on this recent paper by Virgin et al., it was actually one of the key players in maybe not the most important one, but one of the players in the climate sensitivity, the higher climate sensitivity in CAN-ESM. So pattern effects can also be explored. There's also this offline radiative transfer model that Jason mentioned yesterday as well. And so I think an interesting application of that would be to develop radiative kernels specifically for the CAN-ESM model. So that will help with better diagnosing cloud feedbacks. It's more compatible with the model. Also, another potential application is to extrapolate that information to understand band by band in the radiation code contributions from other wavelengths. Like one of the focuses, for example, of the TICFIRE mission is to explore the contribution from the far infrared part of the spectrum. And so having like an offline radiative transfer model will help to better diagnose these feedbacks and help to better constrain that and also tie into the HAWK mission. And then also there is this capability to run nudged simulations as well. So it's been done before with CAN-ESM. And so having nudged experiments will also help with running sensitivity tests. So in particular, if you were to constrain for meteorological variables, like typically air temperature, winds, etc., that can basically help you control for these variables in order to better compare with the observations and better assess and assess the model compared to observations. Also, they're useful for intermodal comparisons. In particular for fields that are known to be poorly constrained and not modeled well in the in CAN-ESM or in CAN-AM, I think that having this capability will also be helpful for model development and improvements. So those are the couple of list of items that I came up with and that I'm particularly excited about.
Yeah, that's great. And you know, given that list, I mean, it's a lot of really interesting directions. What do you see as kind of the work that you would undertake anyway, and then the work that is actually where there are barriers to actually getting it done. So for example, like the single column model, I'm curious if that is in the right shape now to actually do work, and it's just a matter of you have a student and it's setting the student on that, or is it something that you would really currently rely on Jason or colleagues at ECCCMA to really get things going? That's so of the various technologies, the Greens function, the offline RTM, radiative kernel was not developed yet, right? How do you see proceeding with that in sort of like a 3-year sort of time frame?
Right, yeah, so based on conversations with Jason, the offline rate of transfer model is something that is readily available. So I think that is kind of more like the low-hanging fruit, at least, out of the list of potential applications. Jason has already worked with it and has been able to output some of the band by band radiation from the code. So I think that one is, low hanging fruit. I think some of the other items like running the single column version of the model is not something that is readily available. However, we did talk about the cloud model actually in single column mode. So I think that, well, correct me if I'm wrong, Jason, I think that that's something that is explorable within like a realistic sort of 3-year time frame.
I would say at this point it's something that we're exploring. It's not something that yeah, it's a bit uncertain, but it's something that we're working towards. At least internally, that's a capability we'd want to have with GEM. Again, this is going back to GEM spectral model dichotomy, but yeah, I think it's something we're working towards, but it's not something that's, as Neil mentioned yesterday, there's a lot of effort there to move it out going forward. So it's yeah, it's hopeful, but not something that's clear pathway forward, at least for external collaboration.
Yeah, and my purpose in asking that question is not to, damp, creativity and enthusiasm for trying these things, but it's also just to be able to distinguish what would the kind of work that's all like low hanging fruit, right? From low hanging fruit is not necessarily the best tasting fruit, right? So, although maybe it is, I don't know, but the fact is that without there's what we can do without resources, almost what we would do anyway, but maybe with another modeling framework, but we could really do it with CAN-ESM. And then there's the really new stuff, which might be doable and hasn't been done anywhere. And then there's like things that are just can't be doing, that really would require additional resources. A new push for CMAM, for example, that's not going to happen out of thin air, but it's a great idea, but it's something that would require like a big, I would say still a pretty big investment. And so anyway, but
right.
I'm talking too much too, so I would like to have anybody, you speak and have others ask questions.
Yeah, I'd just like to follow up on that thought as well. So with P3, because it's something that's only starting up right now, it's not something that's already implemented. I think that implementing these different schemes into P3, like to incorporate, for example, ice nucleation or, Wegener-Bergenfield Dyson process. I think that's all work that can be done in conjunction with what's going on now. It's not necessarily like the easiest thing or the most readily available, but I think it's a possibility that can be explored. With the greens functions, however, that's something that Jason has already developed, I think. So that is, I think, based on our conversations, we had like, I think Jason has run a bunch of these actually for one of the MIPS as a contribution to one of the climate modeling comparisons. So that is something that I think is, more readily available.
Just to speak to that, I mean, that to me is something that is easily now that you can run the model externally, that is something that easily can be taken up by the larger community to do whatever kind of research. There's not that I'm diminishing my contribution, but it doesn't necessarily require me, right? It's just a single configuration of the model. So it's just having the resources to run it. And if luckily internally we have resources. So yes, I had to run 300 and something simulations in a go. And as people at CCMA know, I hogged the machine and took a lot of runs, but it's just runtime. And then you can start doing a lot of interesting analysis with it. And yeah, that's something that is, I would say that people could pick up externally and start playing with it. That was something of interest.
Right. So like to summarize, I'd basically say that every one of the points is probably more doable than like probably the most strenuous task will be the P3 scheme basically, and improving the ice microphysics in the model. That will be the definitely the most strenuous task out of the others that are readily available and doable, I think, have already been kind of tried and tested.
Yes. Yeah. I think that's really but also that's part of your core scientific interest and work, right? For both is that kind of improving or updating the microphysics in the model. And so there's we talked yesterday about the commitment to maintaining parameterizations and working with them over the many years of a life cycle, right, of development. So that's really important. So 3 years might not be enough, really, right, to sort of fully flesh it out. But it's also worth starting long-term projects. I'm watching the clock here feverishly, so I want to just ask if there are questions and comments building on this discussion before we switch over to Vivek and Yanping.
I just have one quick question, Paul. This 3-year time frame, is it based on the GNC funding from Environment Canada?
No, you know what? It's just a suggested time frame. But what we did was we made a commitment to Compute Canada, and said, we would have this research platform that we would work on for 3 years, and that's their sort of standard allocation. So I kind of picked it out of a hat, but it seemed to me not a bad, because we actually all committed in-kind time support to there's no money attached, but there is some compute resource. And the only GNC funding we received was the 6 months from November to March, and if that's renewed, that'd be great. But since we can't count on that, and since the resources I expect will not be as will be modest, they'll probably be focused more on the technical side. I hope we can do some science with it, but I'd like to sort of that's where the 3 years and the sort of slightly narrow vision on what we can actually accomplish is coming.
Thank you.
Paul, Philip Asin has his hand raised. So Philip,
go ahead. Yeah. Thanks, Danielle.
Philip, ask your question.
Go ahead, Phil. I don't think we can hear you.
No.
You're not muted but your audio is not coming through. Do you want to type it in quickly? I'm sorry, but
in the meantime, I cannot see any other question in our document. So
Okay.
We will wait for Philip.
Maybe while Phil is typing in his question, I'll just mention, I think, a lot of these things are across all areas are going to be like this. And I think the first thing we have to do, and this will come up, I think, a bit in the second panel, is just kind of learn how to work together effectively in this project, right? So I think if we start on these low-hanging fruit things and just learn, okay, if people get experience running the model outside, those are the baby steps that are needed before moving on to like really digging into deep, parameterization development. Like there's that basic familiarity, and so I think we have to go through that growing phase.
Yes, and Phil points out that I'll just read his remark in case people can't see. Graduate student training is an obvious big use case for accessible models, especially training new grad students in downscaling / machine learning. And I would say that what we're talking about, like the learning process, I think will happen through hands-on work by students. Jack Virgin, if he doesn't mind my mentioning, is a student who got to work on this stuff, and it's exactly what we'd like to see enabled by this, to make it as easy for students who are working collaboratively, on these projects to get going, but I think also that the fact that if people, as researchers, we have long-term plans, and so if we can like build our plans around this infrastructure as faculty, trying to like bring in students and bring in postdocs and so on with our own research funds, knowing that we can start to work more closely with CANISM in a hands-on way would be very helpful, right? So it's also good strategically. So it's good to keep both perspectives, but I absolutely agree that we're going to learn from the initial experiences. Okay, so I think what I'll just do is chair here is move over to Yanping and Vivek. I don't know who would like to start. We had a nice talk from Vivek yesterday. If Yanping, you'd like to say a few words to start, or it's up to you. It's up to the two of you.
Okay.
Yeah, go ahead.
Okay. Yeah. Okay. Good. Thank you. I think Vivek gave a very nice overview of the development history of the class and the now classic, the Canadian land surface model, and also you give a nice future projection about what your group gonna focus on. And I would like to comment mainly from a user of this land surface model. And for the last several years, we have been using a lot the US modeling framework. That is the US version land surface model, which coupled nicely with the atmosphere model WRF, the weather research and forecast model. And the land surface model will be mainly used as NOAA-MP. So we mainly use models to solve climate adaptation problems, like how future climate change will impact the Canadian landscape, like the prairie agriculture and the prairie wetlands. So based on our needs, we also do a little bit model development. For example, like the current land surface model, NOAA-MP, they don't have the crop type we have grown in Canada, like the wheat. So we have been doing the wheat option in the land surface model, and the agriculture irrigation in the model as well. So during the model development processes, what we learned, I mean, not just our group is doing such things, but also there's a hydrological group here at the University of Saskatchewan, the big group. They're also doing some kind of adopting agriculture into their hydrological model. So through this intercomparison or model development, collaboration in model development processes, we feel like we should learn from different models, not just the different, models from different countries and different versions, and we should learn from each other and immigrate something we already done or other people already done to our models. This is something we can we don't need to reinvent the wheel and help to save the energy and the resources. So this is what we have been doing, like for the agricultural part, and we feel like in the future we could contribute to the Canadian land surface model development, like something about like adopting the existing agriculture module or agricultural option into the Canadian land surface model. And the other ongoing research direction we have right now is to deal with the wetland in Canada. And for that, we have to start with like develop like groundwater scheme and the wetland representation in the land surface model. And we have been using it to simulate how the future like climate change will impact the wetland distribution over the prairies, and then how this will further affect the waterfowl habitats. And for this work, we collaborate with Ducks Unlimited Canada, which is a very nice collaboration. And then later they start to ask us whether we could do similar things for the boreal wetland, which is in the further north. And then we realize our model limitation, because the non-MP land surface model is developed based on WRF, and the layers, they cannot go much deeper, and they don't have a good representation of a permafrost, which we checked, and the classic can do such things nicely. And so now what we are facing is like we should we have 3 models together, non-MP and CRM, and then classic, and see how can we combine or learn from each other, the 3 models, to see how can we like either change the model or improve one model to do the similar things, but for the wetlands in the further north. So so our learning process is like a problem driven, and then model development, and somehow like through this process we feel like we should learn from different models, and we also would like to contribute, hope like our work can contribute to such improvement of the models. Yeah.
Thanks. Yeah. Go ahead, Vivek, if you'd like to continue that.
Yep, thanks, Yanping. Okay, so I wrote down everything you were saying, and I'm just going to quickly cover what the model is able to do. So starting with agriculture, we have a very simple representation of crops in classic. It's not the most fancy one, but it does the job. And the reason for that is that crops, they get harvested every year, so they do not sequester carbon like forests and grasslands. So from a carbon cycle perspective, we do not kill ourselves to do croplands properly. But of course, on the agriculture side, you have this whole thing, how the crop productivity will be affected by climate change. So that aspect is not looked at in great detail in the model, because it doesn't feed directly onto the carbon cycle, because crops do not store a lot of carbon. On the wetland side, we have a very simple wetland representation. So the wetlands are dynamic. They do expand and contract depending on soil moisture, which is of course driven by climate. And we have done simulations over the historical period to see how the wetland emissions have increased and how wetland emissions will change over time. Now, this is all mostly offline. Okay, so and we do not have any representation of groundwater yet in classic, so that would be helpful, and we do not have any representation of irrigation as well. So again, people have indicated that when you irrigate, there is more evaporation, it cools things down, so it does have an effect on the near surface temperature through cooling effect of evaporation. So yes, so there are 2 aspects here in my mind, is that so remember I said we have a good connection with the offline community, and if but we haven't made a lot of progress on the couple side of things, and Kirsten is the only person I think who I think is more interested in the couple side of things. So yes, we welcome all kind of collaborations. And if you think, and I like your idea that NOAA, CLM, and Classic, and comparing models, because whenever you compare models, you learn things. So definitely, and that's why we have these multi-model intercomparisons. So if you are more than welcome to use Classic offline, it's readily available. It's always at the latest and greatest shape, but it's when get implemented into CANISM, then we have to see what goes in and what doesn't go in. And yes, so if you want to compare Classic's capability on the crop side, on wetland side, yes, you are more than welcome to use Classic. And whatever the community finds, the university community finds in terms of model limitations or the good things about model, we learn that. So that feedbacks into how we improve model further. And if you have suggestions for improving parameterizations, and of course, yeah, we'll take them in, we'll run the model globally, and see what effect does it make compared with observations before and after thing like I mentioned yesterday, and see we don't break anything and everything holds together. And if it's an improvement, yes, definitely, then it makes its way into the model. So other than these things, I just quickly want to mention, because Ivy mentioned a little bit about aerosols. So I was chatting with Knut yesterday, and now we do nitrogen cycles. So we have N2O, NOx, and methane and ammonia emissions coming from fire. We also have ammonia volatilization. We have N2O and NOx emission coming from salts as well. And I am not an atmospheric chemistry person, or an aerosol person, but Knut told me these feed into aerosols. So we have these processes in the offline version, but eventually when it goes into the CANISM, the idea is to use all these emissions to couple it into the atmospheric chemistry and aerosols part, so that part becomes interactive in the climate model. So that's something we haven't explored yet. One other thing is Knut has been asking us to move dust out of the atmosphere into the offline Classic model. So offline Classic, keeping in mind that offline Classic will eventually feed into CANISM as well when the code base becomes a sub-repository of CANISM. And the idea that is right now, when we have dust anomalies, we figure out whether is it due to the land surface or is it due to the model climate. If the model climate is too windy, then of course you will have more dust in places where you have dust. And then you're struggling with, is it the parameterization? Is it the model climate? So offline, we have this capability. We drive the model with different reanalysis data, different land covers, and we can see what the dust looks like offline and see, okay, it's not the parameterization, it's the model climate which is doing this. So we can do these kind of analysis. And when you have that implemented in CANISM framework, of course, then you can simulate the dust burden and compare with these other observation-based estimates. So, but again, we haven't been able to do this. And I just wanted to mention so that people are aware that there's a to-do list here is one, bringing dust into part of CANISM, because dust, of course, is a land surface quantity, just like other fluxes. And the interaction of all these methane emissions and all the nitrogen related species that the nitrogen cycle model can now produce, and somehow use them for aerosols.
Okay, thanks very much, Vivek and Yanping for that. Kristen had a question which was answered related to crops and land management practices. So let's go to John Snoka.
Yeah, thanks. Just a kind of a general comment. I mean, I think we have to be careful about what we're talking about. There's lots of opportunity here to use CANISM infrastructure, things like the single column model when they become available, for researchers to look into and investigate physical processes. And this online offline is a very important concept, because there's downstream modeling that occurs where you can use the model at runtime to get information about crops and things like this that would be very important to targeted information that won't be necessarily needed by the model. But the online is a thing that I think we have to think about a little bit, because if you're thinking of helping with a physical parameterization, in general, in my thinking, as physical parameterizations, what they do is they feed back on the prognostic variables in the model, the primary variables, winds and temperature. And so it's kind of a question you ask at this time, is it important? I've heard things like ice crystal physics. Well, currently we don't advect liquid water and ice in our model. Is that limitation meaning that we're talking about something so refined that it's below that order of problems? And so I think and it's very hard to address these, but one way to do it is to have this, and I'm speaking specifically for the desire to help with development that feeds into the model, interactive. There should be a connection to the model biases discussion, that A4D that we have at CCCMA, because that's what internally drives us to say, if we have these problems with the model, could it be ice physics? Could it be something to do with the land scheme that we need to improve? And that helps us prioritize those things that we should be working on that feed into the model. So I think we should have, and I'm speaking only for the things where people want to contribute and feed back into the model of parameterizations. We need a connectivity to that activity so that, you know, you're really working on high priority things that are going to make a real difference, rather than maybe be an important physical process for your area of expertise, but not really make a big difference in the model because it's in the noise, because of the kind of real coarse way, and Vivek's touched on this, in which we approach some of these physical processes because of the type of problems we have to use CANI-SM for. So I think you just kind of keep those things in mind.
Yeah, I just want to add, this is a general point, so I think it's good for and for the next session as well, is a better understanding of what the priorities are within CCCMA for development on different timescales would help organize that, and without actually putting too much burden on reporting, you know, what you're going to do, and the plans always change, but some like regular contact on what's going on, like we had yesterday, right? But yesterday was a lot of information that people might not have heard, you know, but if we come back at this next year, I think there'll be more familiarity, right? So that's one of the ideas that I think we really have to promote, is if the priority is model bias correction, which it often is, right? And there's work to do around that where you could have, you know, interactions, like that's one of the things we could identify. I'm really sorry to sort of push things along, but we are the time's passing. So I just like to kind of move to Paul and Neil, and you guys can handle the discussion as you'd like.
You go ahead, Paul.
Okay, sure. So I'm going to bring this up in one sense. You know, this is a CAN-ESM meeting, but I'm not directly at this moment a CAN-ESM user. I've been discussing that with Paul, but my involvement really is with the ocean component. I'm an ocean modeler, and I've been using the NEMO model, which is now in the CAN-ESM for many, many years. I've been very involved in the Canadian and international NEMO community, running it as a standalone with biogeochemical and ice models. And then one of the questions that was in the that I was really looking forward to looking at in the Alliance proposal Paul Kushner submitted, and unfortunately wasn't funded, was the coupling of looking at NEMO and they say global configurations, coupled, uncoupled, and how that helps or how that impacts the physical system, the biogeochemical system, etc. So I guess I want to start off as a slightly different point for those of you, I guess, you know, in some of this working with CAN-ESM on the ocean side, there's a very large community internationally in Canada that's using NEMO and is there to interact and does a lot of testing, evaluation, and parameterizations for things that can then go into CAN-ESM. For example, there's CONCEPTS, which is the Canadian government's Canadian Operational Network of Coupled Environmental Prediction Systems with ECCC, DFO, and D&D, that's really looking at the operational prediction side on the marine system side using NEMO. There is things like CANTOGS, the Canadian Three Oceans Downscaling System, which is then trying to take climate scenarios and downscale at high to quite high resolution, maybe at a 12th degree, all around the coast of Canada to look at those climate projections, and then downscale even more to smaller regional scale, ports and other aspects. So there's a lot of work on the NEMO system beyond just CAN-ESM, and there's also MAEPAR, the Marine Environmental Prediction Network, that's got actually a prediction core that's focused on NEMO model development and has created a NEMO forum or community of practice where we're actually working to set up how to share NEMO code, GitHub sites, Slack channels for technical discussions, sharing forcing, sharing results, all of that. So a lot of that will link into the CAN-ESM and into the RPP aspects. And they're two, I guess I would say, separate initiatives, but with a lot of overlap on the ocean side. So we want to really, we want to build this and really work towards these collaborations. Again, so there's a lot of work in the physical system, resolutions, quarter degree, 12, 136, 1/60th, trying to understand process in the ocean side that can then be parameterized, put into whether it's 1 degree or eventually the 1/4 degree, CAN-ESM, the different sea ice models from CICE to LIM2, LIM3, SIE3 are all being also worked on the ocean side. There's also a lot of work in the biogeochemical models. There's people here like Nadia Steiner who could answer this better than me. But for example, there's a Canadian carbon sink project led by Roberta Ham that links observationalists and modelers. And we actually have student teams working with some of these different models, Nadia's group, mine, Katja Fennell's, trying to actually do a detailed intercomparison of the biogeochemical models, how they're representing the gas take-up exchanges, links, especially up in the high latitudes, that is going to be then relevant for those models as they're coupled into the CAN-ESM system. Beyond ice, I know Paul, I think it was either Paul or Neil mentioned there's interesting topics with, like, for example, icebergs. There's a lot of work actually with NEMO and icebergs going on, how to do sea ice locking, how to do mixing, plumes associated with icebergs, provision of biogeochemical nutrients as well. So again, there's aspects that I think going from the ocean community that I think can link in very nicely with the coupled community. There's also right now, because I think you mentioned there was work, people looking at going eventually to the new version of NEMO. We're looking at right now through these Mayapar and the NEMO forum, looking at coupling, upgrading NEMO to 4.2, getting it run on the various Compute Canada platforms. We've learned a lot, so I think that's also going to be valuable for when you're switching to that under CAN-ESM, and for, again, the global Orca configuration, Orca 1, but also as we go into Orca 025, again, running standalone versus coupled. There's a lot of work going on looking at how do we freshwater force it? How do we represent icebergs? How do we represent different represented glacial systems, melts from glaciers, coupling? How do we bring in hydrological models to better represent provision of everything from freshwater nutrients to the ocean? And so there's a lot of studies looking at that in the standalone system that hopefully will be valuable for the coupled system. And as I said, also, we're actually working on getting NEMO 4.2 running with Orca 025, and I suspect our standalone work there will be very relevant for the coupled system as well. So I can discuss and bring in more questions. I think I'll stop other than saying the ocean community, the fact that now CAN-ESM is going to use the same model, I hope leads to a lot more linkage, collaboration, and integration between the two communities, and then looking at how the system changes as you drive it in the coupled models.
Thanks, Paul. That's a really nice overview of how the ocean community is sort of standing ready, and there are some analogies to the kind of other community modeling efforts, including classic standalone, right? And so that's a pretty unique opportunity. Yeah, go ahead, Neil, if you'd like.
Okay, thanks. Yeah, so I think before talking about the ocean stuff, I think I'm just going to back up one step and ask a question that I think is worth asking, which is, why CAN-ESM? Like, why would people that have used CSM or some of the, coupled modeling system want to use CAN-ESM? And I think, the reason that we as a group carry on developing CAN-ESM instead of just downing tools and picking up CSM and, going the easy route kind of thing, or like say, for example, in Australia, they just use the UK system instead of developing their own model. So why don't we do that? Well, because we believe that there's a lot of value in providing model diversity into the SEMA type ensemble or other exercises like that. And it's also the case that these other groups, Australian, American, European groups don't really care about Canada, and so we have a mandate to provide the best climate information that we can for Canada, which, as we heard yesterday, is not only from the global model, that's the starting point, but then there's also all these regional downscaling activities and getting these kind of processes right and projections right for Canada. So I think that's where we see the value, and we hope that for external people working with CANI-SM, there's also value in having model diversity, having a different model to look at. But also, I think it's beneficial when you're doing like NSERC applications to say, okay, we're working, I think there's that benefit of the scientific collaboration, both in terms of funding, but also in terms of just scientific interaction. So that's my plug for why CANI-SM, or at least in my mind. I think the whole process is going to be kind of like slow, like everything is going to be set up on the first day. I think it's going to like, Rome isn't built in a day kind of thing. So I think we have to, the more that these collaborations start, the more the whole thing will get ingrained. So there's not just going to be like Environment Canada will recognize it as more important, the more that it's actually happening. And I hope that it'll be kind of like cyclical like that. In terms of the ocean, I think it's also worth saying it's something, well, it's sometimes neglected. It's worth saying that the ocean takes up 90% or plus of anthropogenic heat. It takes up 30% of anthropogenic carbon every year. And in the long term, the ocean will take up 90% of all anthropogenic carbon too. So the ocean really is this kind of giant in the climate system. It is really significant. And that's why all climate modeling centers around the world started incorporating oceans into their models, where they started with only atmospheric models. They started including oceans into their coupled models because you can't ignore the ocean for projections. And so, if you look at the history of CCCMA, and people might not know this, but the group was in Toronto, and it actually moved to Victoria to try and attract oceanographers to represent this important system. But even though that was done, the ocean group in CCCMA has always been, since day one, all the time, it's been a lot smaller than the atmospheric group. Hence, we've used other models, like now we're using NEMO. We've never developed our own ocean model. I don't think that's an issue, but right now we're in the position where the person that was the leader of the ocean group, Oleg Sayenko, retired. So currently we do have a gap in the ocean group. And so people might have noticed that there was no talk yesterday on the ocean. So that was, to me, something that was glaringly missing, just because there was no one in CCCMA really to give that dedicated talk. So that's where I see this collaboration with universities being super important. It's we do have a lack of capacity. We need to get people coming in. There's going to be, for example, a hiring of a research scientist. And so one of the questions that I have is, what are we doing to make sure that we are successfully, guiding HQP through this process, so that groups like Paul's group or other university groups are training scientists. It's great because they're already using NEMO, but how are we optimizing that kind of pipeline so that then it's really easy for those people to, like, say, get this job in CCCMA that's going to be advertised, and when they get hired, that they can kind of hit the ground running, doing the kind of stuff that we need them to do, with the kind of understanding that we would like them to have, not just about maybe certain physics, but maybe about generally, like, how do things work in a coupled model. So I think that's an important thing. Moving forward, I think we've got a lot of value out of a relatively coarse, like 1 degree model, and I think we're going to maintain that as a workhorse in CMIP7. But we do want a higher resolution, and we do have this mandate, as I was saying, to focus more on Canada. So we're going to try for a global 1/4 degree model for some experiments, and I think we're really leaning on Paul's expertise and others' expertise there is going to be important. And then, of course, there's CanTOD's activity that I think that initially came out of a CCCMA planning meeting like 4 years ago, and it's kind of taken off, but we're still hoping to get money for that internally, and we're still going through this basically begging process to Treasury Board, and we'll see. Right now, it's all being done kind of in DFO, but again, there's I think an opportunity there when we look at important coupled processes, because I'm convinced that if you have like a wind blowing past a headland, it drives this, you have an acceleration of the wind, it drives enhanced upwelling, it cools the ocean temperatures, that changes the horizontal gradient in temperature, that changes the wind field. These are all coupled processes, and you actually miss a lot of those if you're doing ocean only, or if you're doing atmosphere only downscaling. So while I think, this CAN-RCM stuff that John was talking about, there's some things that we can easily do there to provide better boundary conditions for like groups that do ocean downscaling. I think ultimately working towards a coupled system is something that would provide additional value. So That's really something that I kind of hope to see going forward ultimately, and something that I'm advocating for internally. So yeah, I think there's a lot of opportunity to work together, as Paul mentioned, through all these things. And I think now it's kind of a question of how do we actually do that? How do we make sure that we have information flow and HQP flow and knowledge transfer? So yeah, thanks.
Thanks very much, Neil. Kirsten, why don't we take Kirsten's question and then see if we can have some further discussion. Kirsten, go ahead.
Yeah, so this it's I think more comment than a question maybe.
Sure.
So yeah, I wanted to add to Neil's plea for a coupled system. So especially also in this in the space of policy relevant science, right? When we're sort of so CANISM is a fantastic tool, especially with the new developments on the land carbon cycle side. And while we haven't heard much about what's happening with the carbon cycle in the ocean, but I'm sure there are developments there too. So this is a sort of would be the tool of choice to answer a lot of the open science questions that are needed to be understood to inform Canada's sort of 2050 agenda, right? And also to, for example, understand the role of carbon dioxide removal and nature-based solutions in Canada's path to 2050. And so far, a lot of these sort of evaluation of these pathways, and especially in the IPCC world, happens with these integrated assessment models. And we know very little about all the feedbacks. So I think having sort of a coupled tool that really allows us to take all these Earth system feedbacks into account is extremely valuable. And I think very important. So so yeah, I think it is a great tool. To me, the elephant in the room is really funding. Right, sort of, I mean, a lot of these questions, how do we address them? So especially here at the university side, we need people, and we can only employ people if we do have the funding. So to me, this is really the biggest question. How can the community come together and make the case for funding? We have the Alliance grant mechanism, but ECCC is limited in a number of these grants that it can support. So I think there is really there is a gap there. And so I think in terms of university researchers contributing to evaluation, using the tool to answer science questions, I think is limited because of limited funding. Okay, thanks.
Yeah. Fully agreed on both your scientific point and sort of the line from the policy needs to these tools, to the infrastructure. And it's a real challenge, but I think we're pressing ahead, right? We're pressing ahead, like looking at what we can do, but we have to keep making the case for the need for a Canadian model, the need for model diversity, and also for the ever-present funding, both inside and outside Environment Canada too, because I think their funding challenges are found within the institution, so it's very challenging. Paul and Neil, we just have a couple more minutes, but I didn't let you kind of feedback on each other. So like the debaters, if you care to respond to each other, please go ahead before we wrap up.
I also see a question from Jim Christian.
Yeah,
I think Neil and I are in I think what we said is fairly in agreement.
Yeah. Okay, no, I didn't want to set up a false conflict there. So James, go ahead.
Thanks. Yeah, I guess I just wanted to follow up a little bit on the things that Paul said, which I guess relates also to Neil and Kirsten's comments. But I think that, in Canada, we don't have a very large community of people doing global ocean modeling, and I know Paul's group are starting to spin up on that, but there are different academic groups doing regional ocean modeling, but I think it's important to recognize that these are really different animals, that the parameterizations that we prioritize for development for the global domain and the regional domains are very different. right? So I think, like on the biogeochemistry side, I would say, dust deposition and iron limitation and denitrification, nitrogen fixation, and on the physical ocean side, I mean, some of the mixing parameterizations that Oleg developed for CANI-SM5, those are not necessarily the same processes that you would prioritize, if you're looking at a regional model of the Arctic or of the Pacific Canadian continental shelf, right? So anyway, hopefully, as we move forward, that the CANI-SM ocean model becomes more accessible and people start using it in academia, right? So that, as Neil said, that we have a pipeline of qualified people that have this experience, because I think it's important to recognize that there's not people being trained in Canada, specifically in global ocean modeling.
Yeah.
My two bits. Thanks.
Yeah, just to echo that even more, I mean, like when we put out adverts for people with this expertise, we don't get anybody applying. And I don't know why that is. We're advertising wrong, or people don't want to come, or that people don't exist. But it kind of, I mean, I think there's this overall skill shortage, but I think particularly in these like really specific areas, people that know how to run these models, and even though there are several academic groups using NEMO in Canada, which is a bonus, the HQP pipeline still seems to maybe not. Well, I would say we're struggling to find people with the expertise.
Yes, and it's not a huge market of people you need, but well, first of all, I don't know how aware people are of the loss of one of your core experts within CCCMA. That's not really well known, so it's really it's good to have it aired here, and to know that there are opportunities. But again, I want to come back to that point that, in terms of the flow of information, it does help to hear what the priorities are. Actually, James' point is really good. I think it reflects, it is consistent with what John Sunoka was saying, was at the level of resolution of CANI-SM right now, we are interested in high resolution ocean modeling as well, but at the current resolution, there are still priorities focused on, bias correction, and maybe like really large scale questions. If that information about those priorities is kind of communicated more frequently, that might partially help. It's not a solution by itself, but it might help a little bit more. So I'm looking at 2:05. I think we were supposed to finish up, just a couple minutes ago, and I did want to respect the time. So Daniela, what's the next on the agenda?
Yes, the next item in our agenda is break. And we can reconvene, 10 minutes break.
Okay.
So maybe we can reconvene at 2:15 just to give them the 10 minutes break.
That sounds really good. Yeah, let's do that. So we'll end slightly late, but let's take the full 10 minutes. See you soon, everyone.
Yes, see you soon. So maybe we can start again. So I will welcome Neil Swart, who will moderate our second panel about the CP4C, Science Application and Collaborative Environment, and who will introduce our next panelist. So the floor is yours, Neil.
Thanks very much. I'm just going to share a few quick slides to get us going here. And so I'm Neil Swart from Environment Canada. And I'm really excited for this panel. So thanks everyone for joining. Like the first panel, we strove to have a balance of people from internal to EC and external. So we have Joe Melton from ECCC, Andrew Shao now at HPE Canada, Hansi Singh from UVic, Glenn Sinan from ECCC, Jack Bergen from Waterloo, and then John Sunoka from ECCC. And prior to today, we had sent the panelists the goal of the panel, which was basically to generate ideas on how to optimally structure the CP4C initiative so that we can provide the maximum value to all participants, and we can end up delivering improved climate science information to Canadians. And then we listed 4 specific questions. And so my plan is basically just to show the questions, give them to the panelists, and let them discuss. And so the first question that we had is, what types of policies or guidelines should be established to ensure that CP4C functions optimally? So we're thinking here of things like code of conduct, code and data sharing policy, the attribution and publishing of data, how code developments that people do might be integrated upstream, what different roles and responsibilities should be, etc. So with that, I'm just going to kick that question to the panel and see if anyone wants to volunteer to start us off.
Yeah, I mean, I'm happy to kick it off. I mean, I think the one that pinged on me most of that when you guys sent around the email was the roles and responsibilities aspect of it. You know, I think because there's such a large group of people who are interested in CAN-ESM5 and using it for science applications, it's, I think, crucial to identify who wants to be like a full pipeline user of it in terms of like, I want to develop, compile, run, and generate model output versus like somebody who's more interested in one segment of that full pipeline. And I think like trying to figure out like not just administrative roles, but like kind of that level of user role, I think would be really interesting to hammer out, and then because those people can then be kind of useful resources for each other and communities for each other. So like someone who wants to use CAN-ESM5, but really does not have the capacity to do anything other than look at output, has a very different role, obviously, than someone who, you know, is like, I don't really look at the output, I just kind of know how to run the model. But both are incredibly useful to any kind of scientific collaboration.
Yeah, I guess I can jump in just to make sure. Okay, my mic's being picked up. Yeah, I mean, obviously coming at this from more of a technical standpoint of things, and I'm kind of, yeah, like it's similar answers to a lot of the questions kind of for me, but where there needs to be some pretty obvious testing pipelines for people. In my opinion, we're going to be doing this kind of in a collaborative nature across all these different groups. We need ways to be ensuring that people's changes are doing what's expected, make it easy for other people to evaluate other people's changes. Basically, I think one of the big tenets of a project like this is reproducibility needs to be at the core of kind of how we're doing this. Like we're doing this in a collaborative group, right? So if just one person runs it and gets some answer and they're really excited about, since we're all using the same platform, we should be able to take their stuff, take their configuration files, and then should be able to reproduce it. So yeah, I think that kind of needs to be at the core of kind of how we generate some of these policies and guidelines. And that also comes with a lot of infrastructure that's necessary for that. But obviously, yeah, that'll take some work. We'll have to work on it together.
One thing that kind of struck me when I was looking at that list was that you know, like it's nice that CP4C is already looking at this, because I kind of think that you know, you want to really maintain like the goodwill and trust of the community, because you have two really different user groups. You have the government, you know, we have these long time horizons, our staff turnover is low, we kind of can plan long term. And you have the university community where they have, because of their funding, you know, they have to kind of do these more short-term projects, and that they have maybe 5 years of funding, and then there's no guarantee that they can continue the work. And so I think, you know, these documents kind of need to help lay out the kind of ground rules, and so that both sides can really profit from this. And I think that that's something that's pretty important to ensure the longevity, so that, you know, people don't feel burned because, for example, they came up with something really nice and it wasn't taken up by the model group as a whole, but, you know, that wasn't clearly laid out, like what they had to do to get it taken up by the model community as a whole, what they had to demonstrate. And so perhaps, you know, like, you know, just the fact that you're already thinking about this is actually a really good way to go, because at least you're already starting to lay the ground rules of what it means to interact effectively.
Yeah, and that's actually a really good point, and I'll just highlight that that's one of the things that the NEMO consortium has actually is recognizing it has been a struggle in the past. You know, and this is, again, like, you know, supposed to be a consortium of equal opportunity or equal members and all this stuff, but in practice what ends up happening is like you have to tap somebody that you know you know, and get them excited, as opposed to it really being on its own merits for inclusion. And so like, that is a extraordinarily difficult effort. I think there's also the opposite end of the spectrum, which I've seen, where it's like you just kind of hoover up everything, right? You're like any and all contribution is welcome, and that also has its challenges because you don't know how to really manage all of the external effects that development might have. Or you might not be aware of the opposite way, right? How other developments may interact with yours. So I think that goes to kind of like Clint's topic, where he's like, okay, like kind of the testing and validation kind of sort of needs to be in place as well. And then to Joe's point, being clear about like what do you have to demonstrate in order for it to make it and for inclusion, and then like what are the actual just like hard and fast rules, because the hardest thing in the world to deal with is when there's soft rules, unspoken rules about how things might happen, because either that like you said, you can kind of feel slighted personally because you're like, oh, Joe doesn't like me because he didn't reply to this, or like, but whereas it's like, oh no, like this test didn't pass, so you need to fix this before we can elevate it to the next level, and here's the kind of formal process by which we'll take things up.
Mm-hmm.
Okay, so that is a good point. So it sounds like, really clear, explicit guidelines and expectations for the conditions under which things come back in. And yeah, I think that's valuable. So maybe I'll ask Kanzi and Jack from, working in universities, what they think about any of these points.
Yeah, so my experience in this type of modeling effort has been with CSM, which is larger. But the way that model really stays sort of abreast of what folks in the university community are thinking about and doing and deem to be interesting and useful is through working groups. So like I'm co-chair of the Polar Climate Working Group, and so each of the working groups has a university person in it, and then a person who is from NCAR, which is the development hub for that model. And the usefulness of that is that you automatically end up bringing in folks both from the Development Institute side and from the university community. So you get all of that sort of, that more rapid churn of risky ideas, and, kind of more fertilization of what could be, kind of a potentially like kind of unchanging institution, as you said, Neil, right? And so I think that is partly what allows there to be, I think, so much good collaboration that goes on. And so each of those working groups is like devoted to both model development, but often on the university side. I mean, most of us are users, though we often play with model development, right? I'll hack some code or something. And I think that the other thing that's useful too is that if a university user or a user who is not from the institute, where the hub of the development is happening, wants to do some development, I mean, that can always be a branch. It doesn't need to be like trunked, right? So this makes version control really important, and version control particularly for sort of add-on modules that might be useful for specific disciplinary users. So I think perhaps some sort of, way to get the university community involved particularly would be useful in this case. And the other reason why I say that too is because when it comes to a model in which it is difficult to, even be able to know in any way how to run it without specific feedback from the institute that's developing it, which is very different than CSM. CSM, there's these workshops, these tutorials, so much info online where, if you can figure out how to port the thing, which is, kind of a pain, but if you can figure that out and you can get help with doing that, there's a lot of resources online to help, then, like you can run it, you can do whatever. It's very decentralized. But in this case, it's less so. And so in that case, I think it is really important to get the folks from the university community, like, very closely tied to folks from the development hub. So that's my input.
Great, thanks so much, Andy. We're just going to see if Jack had a comment from the university side, and then I see John has his hand up, so then we'll go to John after.
Yeah, just want to make sure my mic is working. If everybody can hear me. Good.
We can hear you.
I definitely agree on the kind of close-knit collaborative nature between the university and ECCC for sure. But I also think that like one of the most exciting things as someone who also just mainly uses CSM, but also kind of tweaks and messes around with it a little bit, one of the most exciting things for me would be kind of the possibility to operate CAN-ESM a bit more autonomously. I know that when Jason and I were working on the equilibrium climate sensitivity question, it was a lot of back and forth, and kind of me being reliant on Jason for data and simulations. And this would definitely help alleviate that, obviously, but would really help would be kind of maybe what the second point, what Neil was saying, was infrastructure to support us as far as practices and documentation, because I don't want to have to be working with the model and maybe run into an issue. And if there's extensive documentation where I can help myself before I have to essentially bug somebody from ECCC, I think that would be fantastic, because as we all know, everybody's strapped for time and resources. And I think that as far as getting off the ground, as much as, you know, as far as research collaboration is concerned, that's a great thing. But as far as just kind of on a day-to-day getting things working, I would really put a lot of stress on documentation to kind of maybe minimize the amount of back and forth for small technical issues that could be alleviated just with the right kind of page that says, this is an issue, and here's how to fix it. So that's one thing that I would put a lot of stress on for sure.
Great, thanks. Yeah, and I think that's really aligned with what we do. So like, you know, internally, that's really the way that we've gone. And we also have that for all the external stuff, right? It's all just on read the docs. Anyone can go there, and, you know, like these students that spoke yesterday, those people had all just run through those instructions. So it's certainly not perfect, but, you know, within our resources, that's the way that we're attempting to do it. And within CP4C, we've been asking, how can we allow the community to build that resource more and more? So, you know, like if someone, they'd say that Haruki learned a lot about how to run the model, then you could kind of, you may, you know, have a forum where guys could interact with each other, like a discourse or whatever. So yeah, great ideas. So I'll go to John then, thanks.
Yeah, I think we're at the start of this, right? So we don't have to solve everything at the beginning. And it might be really helpful to make the distinction between application of the CAN-ESM outside of, you know, CCCMA and ECCC, and development, that feeding into it and helping to change it. Because I mean, that development hits on a ton of issues to do with testing and legacy and maintenance of it. But application, and I take Jack's points and Hansi's point, that people need to run the model before they can do anything else with it. And there is so much interesting science that you can do by just running the model with doing interesting experiments, you know, hiatus and warming, COVID, reduction in CO2. That's available in an autonomous way by people on the outside. I mean, they may want to do it in collaboration. They may need a little help to tweak it. You may get some changes to the model that are more structural and infrastructure to support these types of experiments. But as a starting point, it would get people familiar with running the model, comfortable with the model, testing to see if the things that have been put in place are useful for people outside the group, and refining that. And it also fits on the timescales of academics' funding cycles too, right? You can do some interesting science on a time scale of a year or two in an application. So, I mean, in terms of these policies and so forth, if we started with application, I think we might be a little bit easier. And then as a living document, we begin filling in about how, you know, things come back upstream, and there'll be some interested parties in doing that initially. So they will work on the protocols and everything that will inform policy, but maybe we don't have to solve that right away if we kind of look at applications first.
Yeah, those are good points, John. I want to come back to that, but Mike Lazar and Paul have their hands up. So yeah, I wanted this to be as interactive as possible. So I'm going to go to Mike, and yeah, Mike, please say your question.
Okay, just at a point of reference, we went through this about 30 years ago with the Climate Research Network, and they funded 6 nodes. Each of them had their own PI, and you know there were MAM, RCM, aerosols, ocean, land, and paleo. And the reason it was limited to 6 was they recognized that we didn't have the internal support to do more than that. There were concerns about if you had constant questions from grad students, coding standards. So they limited to 6, which were the known important issues of the time. And there was one support person that for getting stuff in and out of the model. That was myself. And I was outside of CCCMA. I was outside of the group, so they didn't have to take up resources from inside the group. And I'm just wondering, I know we've talked about this, but we don't have a lot of people here. And not only for the support side, but also the scientists within CCMA who have to respond and interact with all of the other users. How do you prioritize people who want to use the model, or are you going to set certain number of users only or groups only so that you don't have to deal with the rest of it? So these are all things that came up in the past and I think are still relevant now. And this is only on the development side. I agree with John about the other side.
Yeah, absolutely. I think these are good questions, and we have to be cognizant of the reality that an institution like NCAR is like 10 times bigger than an institution like CCCMA. And so there's just, and they've got a mandate to provide a community model. Like our management doesn't give us that mandate. So yeah, these are all things that we have to be honest about. And I think yesterday we saw that there were a lot of people that were excited about collaborating, which is great, but we do have to recognize the constraints that we're in. But I think this kind of scientist to scientist collaboration, which kind of is, I think, aligned with Hansi's working group kind of idea, I think it's something that could work fairly well. Okay, Paul, yes, please go ahead.
I think Joe wants to respond, Mike.
Yeah, you can. If somebody wants to respond to that first, go ahead. It was a more general point to make.
I just wanted to note that the difference between like 30 years ago and now is that we have a lot better tools now to enable this collaboration. Like we can have documentation that is user editable. We have version control. We have all of these other things that make it so that the burden of that interaction is hugely minimized. And so I think that the general point doesn't get around the fact that we're under-resourced, but the kind of scariness of it is heavily reduced by the fact that we have so many good tools now.
Yeah, Joe, I was going to mention that you're already doing that, and you're right. So you're already dealing with all this on your end, and you've been doing it for a few years. So that in the ocean group, it's not so much of an issue, it's the atmosphere.
And one thing that actually just that I wanted to also hit on is that documentation, actually this came up with Jack's comments and Hansi's, I think, as well, is like documentation, not only for like, how do you run the model? Because then that avoids this, or these like common snafus or whatever, that avoids this developer drain where you get like the one central person who gets pinged with everyone's question. And then they just waste all their time doing that. So if you have like really good documentation, that can help. And then there's the other side, of course, if people are trying to push something upstream, obviously to get at John's comment of yesterday that like, his concern was he needed somebody internal who understood, say, something new that was coming in. I mean, if you have, absolutely excellent documentation and excellent like characterization, that can relieve that stress a bit, because honestly, I don't remember stuff I did 10 years ago. And so I don't expect me, never mind, if the person is gone, to know. So that's why documentation is so important. Anyway, I just wanted to make those points.
Yeah, no, I think we are in a good place where, I think we basically have the gold standard in version control. I think we documentation and automation is really good. So I was thinking the other day that kind of like a joke is like, I think my dogs can run CANI-SM. Like if I just got a button that they pushed a button and then kibble came out and then they kept on pushing the button, it could launch simulate. Like we could do, like I could set that up. So it's possible. So like, that's how easy it is to run the model. And that's one thing. But then, the problem is that the dogs don't understand what's happening inside the model. And as soon as you want to do something more complicated, and it's the same for people, right? Like running the model is one thing. It doesn't necessarily take a lot when there's these super good instructions. You just follow a recipe. Anyone that can follow a recipe can do it. But then as soon as you want to start changing things and all of that, like that's where the more difficulty comes, I think. So yeah, it's documenting all of that process for change and so on.
Plus,
yes, Paul.
Yeah. So I wanted to just quickly say that I'm trying to come back to this RPP that we've gotten support for, and there was a commitment, there was a management strategy. I'll just mention that was the one thing we got dinged on in our review. It said it is a very good initiative. However, the management strategy for the portal seemed not well developed. And so, but what we did say we would undertake as in terms of a strategy is that we'll establish a management team consisting of myself as project manager, Neil as technical lead and liaison to ECCC, and one or two other co-PIs whose projects are active in that year. The management team will be responsible for CP4C status review, decisions on allocations of our whatever CPU resources we have, communications with partner organizations, and workshop organization and other community activities. The point is that any resource request, anything we have to have a structure, a management strategy, and in our Alliance mission proposal, we talked about these specific issues. And I think that this is a great, a great discussion, and it's like Joe said, we have to starting to talk about it right away before we get too far into actual activities, and that we're really trying to be transparent and returning to the question of how resources should be used. I think that will help a lot, but we do need people. And so, we don't necessarily need a lot. In fact, the co-PIs on the proposal said, we don't need everybody every year. Why not have a rotating membership? Ultimately, I would like to see something like the CESM working group structure. And I served in that structure as well. And I think that was really, it was really great. So this is all part of what we need to work on, because of course, when you bring in outside users, then you have to be careful about what's expected and what the terms of reference are. So there's some administrative work to do, but I really do think we can handle it at a level that is commensurate with the resources available. And could I just say one more thing? Sorry, Neil, to take up too much airtime, but it's been said a few times that university researchers are necessarily thinking on a short time scale. And I would say, I could discuss that. I think that's true for some of the work we do. I think it's also true of some of the work you do, that you have things that are cooking along long term, and then you have things that you have to do really short term. The number of times I've spoken with people at ECC who say, oh, we have something that just came up. It was supposed to be ready last week, right? How many times you have to switch gears. So as people training researchers over like a 10-year period, right? Like I'm really looking at a decadal time scale for my kind of research and work. I don't know how different we are in that. I know what you're saying about the resources on offer, but I don't actually know in terms of the actual work we do. If you look at a lot of our research programs, they don't change that much from one funding cycle to the other. We might dress it differently, but it doesn't necessarily change that much. So what I'm saying is we have a lot of similarities, although within government and outside government, very different jobs, but we have a lot in common, especially in the space of model application development.
Great, thanks, Paul. So I think, a couple of the other questions for the audience that didn't show on the slide were, what infrastructure do we need and what might a government's model for CP4C look like? So I think we've started to touch on those questions, so we don't necessarily need to go to them explicitly. And we can talk more about those things for sure. I wanted to come back to something that Pansy had mentioned and John had kind of mentioned, which was really about running the model. So people being users and being able to do interesting science questions. And in particular, coming back to the kind of like policies or guidelines with respect to this. So one thing that we spoke about yesterday was putting in place this full diagnostics pipeline so that when you run CANISM, which is what happens when you run it internally, like Seymorized netCDF comes out at the end. So it's like, it's a very official looking format. When you run CESM, as far as I know, you don't get that. You get the raw CESM output. It might be more usable in CCCMA format, it might all be in netCDF, but you're not getting the full Seymorized netCDF. I think there's a legitimate concern from some people in CCCMA that if this is really easy to produce, like if my dogs can produce it, like I say, pushing the button, netCDF, like Seymorized netCDF comes out, do there need to be any policies or understandings or agreement on how this is used, how it's published, how it's used? Because, if once that data is then kind of like inserted into the broader community, it has this appearance of being ultra official, right? Because it's all fully Seymorized. Does there need to be any thoughts about what the policies are about attribution, about what should be published, what shouldn't be published, how are things described? This is something that I'm interested to hear what people think.
I think that it's an interesting philosophical question, and I think that where it comes down into play is that, we like once a model's out there, and if there's enough information where like literally your dog can run the model, then it's kind of out in the open, and people can do whatever they want with it. And I certainly have seen some interesting studies where people have used CESM to try to prove the young Earth the Earth is 10,000 years old hypothesis. Certainly nobody's name shows up at NCAR on that paper, but it's kind of an interesting thing, like that. And what it makes me think of is that maybe the right way to do it, in case there ever is that blowback, right? Like somebody in the government just gets sent a request being like, oh, we saw this wackadoo science paper and it used KNESM-5. Well, they're like, we know how to authenticate things, right? We like I'm thinking like SSH keys, right? It's a form of two-factor authentication where it's like someone can be like, yes, legitimately, I signed this data, and you can just authenticate that right away. And if it doesn't match, then well, you say like, hey, look, we didn't run this. None of us signed off on it, and so I may just recommend that as the way forward. That in the metadata for a file, anything that comes out of this consortium just has a given key associated with it, and then you kind of you just chuck it and be like, it's out and open. And that was kind of what we wanted from the first place. But the only things that come here that are minted and confirmed as coming from the group is that are these signed diagnostics.
And from the perspective of like Classic, what we've been doing, I found so far that there's actually not a lot of people kind of just taking the model and just doing whatever they want and not kind of connecting back. Because usually what happens is they start doing something and they got questions or they're curious, so they start to connect back in. And so I don't know, even if it's press play and go and that's all you do, I don't know if there actually would necessarily be that many people going out and doing that without kind of connecting back in with somebody who knows the model well to try and see if what they're doing is correct. I mean, most people want to ensure what they're doing is reasonable. I mean, trying to prove Earth is 10,000 years old, that's a whole other thing. You've got other problems. Another kind of check that seems to happen is that you get, when it goes to review, like who the reviewers are going to choose, well, the people who are experts in the model often. So again, you get kind of connected back that way. So I kind of think this sort of thing, it's one of those things that kind of sounds scary ahead of time, but actually probably doesn't amount to much. That's my impression.
I'm one of those people who are scared of it, only because, and I take Andrew's point, it's in the wild. And you can say, for example, CCCMA is the only one who makes a contribution to the CMIP exercise. I don't think you can say that anymore once it's kind of out there, because people have access to the model. And I know certain scientists, even in the Canadian community, who might even be interested in running our model to make a separate contribution. It's not unheard of. We actually thought that might have happened a few years ago, but it's a possibility. And it makes you wonder, is it a bad thing? Because if they don't do kind of due diligence, and we try to do due diligence, but still we come up with a climate sensitivity highest in the community. And we spend a lot of effort trying to figure out why that is. Now we have two models that somebody might not have put that care into and show some kind of strange behavior. Is that a property of our model, or do we have to down tools and not only look at the behavior of our model, but then demonstrate why what they showed isn't indicative of our model and it doesn't inherently have that problem? I don't know how to solve that. I mean, but it's just it's a concern, but it's not something that should stop this exercise, because there's potentially too much value in this exercise for us. It's just something to be kind of aware of and kind of keep an eye on. But I take this point of Andrew, it's in the wild, right? I don't know if you can set a policy. You would almost be telling people what science they can do and can't do with it. And I don't know where you draw the line if you go down that road. So
I think for me, that's where it's not necessarily these intentional bad actors, let's say, right? I'll give you an example. Internal to CCCMA, we have this question all the time. We just, for this tuning exercise, generated the massive large ensembles, like hundreds and hundreds of members with all kinds of perturbed physics. And a lot of those were in like deep out of space in terms of what the climate looked like. There was only supposed to, allow us to find this couple of ones that were actually plausible, that had the properties that we wanted. But there was a big debate that went on in CCCMA about, should we just dump all of these things out there in the wild, like the data, and people started using it. And because it's got the Seymour-ized NetCDF, some people actually put it on IFTP servers, people started downloading it. And there were these questions about, like, people might not even know. Like, so the person that ran them was in CCCMA, they didn't have bad intentions, they had excellent intentions, they were trying to do a legitimate science project. But sometimes I just feel like if we have guidance that can help people to know, okay, this is an appropriate way to document what you've done so that everyone knows it's very clear what this data is, how it should or shouldn't be used. I think those things are kind of important. Even if it's not to defend against bad actors, but it's just to help people that are well-intentioned do the best thing and communicate with their colleagues as well as possible.
So the way that CSM deals with this issue is that there's particular scientifically validated configurations. And those scientifically validated configurations are the ones that, you use when, you run the model for CMIP or something like that. And so everything else is just, you're on your own. There's no scientific validation of this. So I think putting that rubber stamp on there is possibly useful. And then anything that anyone else does, like, that's their thing, right? That's not your problem. So, I mean, that's the, I don't know. Andrew, I haven't heard of this 10,000-year-old Earth thing. That's super bizarre. I generally, like, speaking, I mean, I know you're saying, the dog can run it, but I don't know, like how many dogs know about HPC computing, right? Like, how many dogs write, computing grants on Compute Canada and, figure out Slurm. Like, I don't know, maybe a lot of them do, but I suspect that it's a pretty small pipeline of people that have the expertise. And I think if you just put that rubber stamp on, these are the things that are scientifically validated, and the rest you're doing your own science and have fun in peer review, I think that's good enough.
Yeah, I very much echo that point, Andy, because it's, like, there's a certain level. It's like you have to have basic understanding of running something on HPC. So there's already a fairly large activation barrier. Like, it's not someone can just download on their Windows computer at home and run it without, like, breaking their system. Like, there's going to need to be, there's a technical barrier that kind of inhibits and gives a bit more expertise to the people running it. But then I think it even comes back to my point about reproducibility and kind of how we lay out how to do reproducible science with this platform, right? Because, like, if someone comes back, well, like, I guess in most of this, I'm just saying we just need to rely on the peer review process in ways, right? Like, if someone comes and they have, like, look at this crazy result from CANISM, and then the question is kind of, okay, how could I reproduce this on this collaborative platform? And if they can't give the reviewers any valid way of how to reproduce it, then it's then I think it kind of falls out in the wash. Obviously, we need to find ways to avoid it and still safeguard against it, but in ways I think it's scary, but it's also something that I think can be dealt with in the scientific community.
Okay, thanks, Glenn. Yeah, so just to echo, I think that what Hansi and Glenn are saying are kind of aligned with what we're doing. So, we have the DEC simulations, and whenever we move to a new machine or a new model version, we always run DEC, and we intend to publish that formally on ESGF as CCCMA. And the CP4C project also has the goals for this year to run DEC, and that would be these kind of scientifically validated configurations. So it would say, okay, we've taken it, we've run it on Niagara, we've got basically the same climate as ECCC had on their computer. This is what it looks like. So if you go and run a historical simulation and it's got half the level of warming, well, then you're doing something that's not consistent, right? So, okay, yeah, Jim.
Thanks. Yeah, I think you mostly said what I was going to say anyway, but I mean, going back to Clint's point about reproducibility, and I guess what was said in some of the talks yesterday about, when you port the model to a new system, you're almost inevitably going to lose bit for bit, right? So bit for bit, I mean, the bit for bit is easy, but it's going to fail that test 90% of the time. So I think one thing we can do is provide users with a set of benchmarks, right? And that gives people an incentive to, or maybe create a web space where people can upload the results of their benchmarking, because that gives people an incentive to feedback and let us know what they're doing. Because I think, once you lose bit for bit, is the climate acceptably the same? And look, what is your benchmark for, acceptably? And this is particularly problematic in the ocean because the ocean takes a long time to equilibrate. Anyway, I actually have to leave for another meeting. I'm sorry. I'm kind of late for it already, but thank you very much.
Thank you.
Thanks, Jim. So I think we've had some good discussion on that. Coming on to some of the other ones, I guess something that came up earlier was this elephant in the room being about the funding. And one of the questions at the end was, how can the CP4C activity kind of promote itself? And we've heard yesterday that there was this NSERC proposal, and we believe that what we're talking about here is really aligned with things like this Climate Science 2050 policy document. Yet, we haven't been successful at NSERC to this point. We hope to be in the future. I think we intend to continue pursuing that. But I think if we can build momentum and things that these days depend a lot on marketing, and if people who knows that, or who thinks this is important. So I was wondering if people have any ideas about ways that they think that this project can advocate for itself effectively.
I have kind of an idea. So one of the things you had mentioned earlier was like a governance structure, it seemed like, for CP4C. And I was recently serving as a deputy scientific director on an NSERC strategic network. And I would meet a lot with our board chair, who was a deputy minister who retired from the public service. And I found that it was really interesting to listen to how this person thought, because they understood like funding, they understood like, how do you get kind of exposure? How do you get people interested in what you're doing, et cetera? So when you're pursuing a governance thing, you may want to think about having, of course, your government and your academic members on your governance, but actually turning an external person who has this expertise in like how money, like funding functions, and that maybe they can help you do. Because I really found it interesting and I learned a lot, and I think it could be valuable for this exposure, because otherwise, the kind of exposure levers that we have are pretty limited, whereas somebody who understands deeper might be able to give us a boost.
Nice suggestion, Joe. Thanks. But just drop something in the chat saying a code of conduct and licensing agreement would address a lot of the concerns raised. Yeah, I think that's a good point. Any other thoughts on kind of the governance structure? Like, what should it look like? Was what Paul brought up earlier something that people think would be adequate, or do people have suggestions other than what Paul had earlier suggested?
Does Mike have his hand up? I don't know if Mike Lazar, you have your hand is raised, but I don't know if it was.
No, it was actually related to the bit for bit, so I'll come back to the end if there's time. Don't want to interrupt this one now.
I mean, ultimately, I think the governance structure, yeah, that's a hard thing to kind of nail down exactly kind of how we want to set it up. I think I really do think that, like Hansi's point about working groups, I think is a good way to kind of have this trade structure that we can kind of use, where we have university interaction at all these levels. And then, because if you just kind of put it on like a group of 3 or 4 PIs or something like that, I can imagine that then that's kind of how you might have things kind of fall off on the wayside, where they're like, we don't have time to go back and look at this proposal that someone put in. So if you have kind of this like more potted working group structure, I think something like that will be particularly useful, because then it's like the working group will approve and say, this is something we want in, and then that's kind of how that comes in. And then obviously there's these other things about like, as Vivek's point about licensing and code of conduct stuff, those need to kind of be fleshed out as well. Yeah, I really do think there needs to be some sort of trade structure in with this like working group model in order to make it sustainable.
Thanks, Clinton. Yeah, so for people that don't, so in in CCMA, we do have these kind of natural working groups like atmospheric working group. We have a coupled model working group. There's an A4D, the analysis for development exercise that was presented yesterday. And there was some discussion about drawing in additional people to those things. And so, those things have typically been internal, using internal issue trackers and so on. But I think, an easy thing that we could do is just try to open those, crack those up, because the structure already exists. So if we just crack those open a little bit and invite people, and so I'll do that right now. If there's people that want to join the couple model working group, or probably any of the working groups, if you get in touch with the people in your area, I'm sure they would be happy to welcome you into those if you're interested. A lot of people don't have the appetite for sitting through hours of discussion about all this technical stuff, but if that's the kind of person you are, then certainly you'll be welcome. Okay, Paul.
In terms of governance or sort of like the larger structures here. So I'm serving as chair of ARCU, which was sort of the umbrella under which this was organized, and I'm stepping down as chair, but I'll be reporting to ARCU, and Hansi's on the advisory board and will be joining the executive next year. So that's been a kind of semi-informal mechanism. It's not an incorporated organization. But we do have some structures in place. I really appreciate, though, Joe's point about, working the network a little better of people who could really help with this. But I do want to sort of start less ambitiously, because I still don't have a clear view of how this is all going to work out. It's not going to be CESM, overnight, but. So our management plan for now was focused just on the compute resource and the compute, like the plans of working, seeing how we do with what we have. And if we're successful in getting some additional GNC funding, that would be great. If, because I don't think we actually need a lot of money right now to do the kind of activities that we're starting to talk about here. In other words, the overall vision that we're aiming for with the NSERC Alliance mission, we can't do that without substantial funding, but we can get started on many things. So what I think we just need to keep thinking and revisiting and maybe writing some framework documents, writing some ideas down, seeing how it works in practice to start collaborations. I think it's a very nice invitation, Neil, to collaborate, and if that's that's something that you need to discuss more internally about how that would actually work with extramural participation in the working groups. I think that's a great discussion to have, and I'd be very interested, of course. So I think there is an appetite to get going, so. I just don't think this is going to happen through meetings exclusively. It'll happen through working on it at the same time. So yeah, I don't know if those points were coherent enough, but we do need help, and even just with the compute resource, like the current project, we definitely need help. So if anybody wants to help with that part, I sent everyone the proposal. I have some co-PIs who are actually committed on paper, but I think anybody who wants to contribute in-kind time to help us with this research platforms and portal project, it would be great to have your commitments there, and we can start with that.
Yeah, I'm talking about that invitation to meeting. So we have this group, Paul and I and Daniela and the students that spoke yesterday, meeting to kind of get things going, and like, how do we actually run the model on Niagara? So yeah, I would say certainly anyone's welcome to join that if it is something that you want to do. And I think Paul mentioned before that we'll probably have a tutorial later in the summer about like sharing the knowledge that group has generated, how to do it.
Yeah.
So Paul, we are at the end of our time. Is that correct?
Oh, that's true. Or we said we would go a few minutes past, but yeah. But I'd love to hear. I think there's 2 participants who've raised their hands. I see. Who are those, Daniela? Well, that was me. I'll lower my hand. And then John as well. Yeah, John, go ahead. You were actually on the panel, so go ahead.
Yeah, I just I don't know how much computing time you have, and doing all these technical things like working out efficiency of the model is all quite important. But if we could focus on one scientific project, it's a little bit of success can be kind of move things along. And maybe we could think of a project, a very interesting application of the model that would be just an experiment. And if we focused on maybe having it collaborative between CCCMA and the universities, where half of the ensemble members are run by us and half by the university, just because that kind of application highlights the fact that just how portable this is, right? And it's some sort of like thing that you can always point to and say, this was done in collab. It wasn't just like we passed you the model. What did they do under the hood? Did they, do something? Is it a separate action? No, this is how well it runs, that half of these runs. And so we can stump up computational time, which is not difficult for us to do. So if we could identify, and this could be in a working group like Hansi has described, but something that we could say, you have enough resources currently, even under the funding that you have, to do some runs. And then we could fill out some runs. And, maybe we do a little bit more, who knows? But it's an interesting piece of science that goes into a nice high profile journal. And you can point to that. You can wave that around as a success. And the nature of that success being this coming from both places, because I think that might be a thing you could get a lot of mileage out of. And it's this simpler type of application. So, and there's lots of ideas for interesting scientific problems to do that might be kind of within striking distance of the amount of computer time that you have. Yeah.
One kind of fun thing to do with working groups is, so Neil, that was kind of an interesting thing that you said about, these are like the version of these working groups that you currently have in CCCMA are super focused just on the development, right? But maybe members of the university community don't necessarily just want to do development, right? So you might have kind of like, as I said, like a CCCMA person who is, one of the heads of the working group that focuses more on the development side. And then you might have like a university community member that focuses more on the science side, and they do liaison with each other. And there's some overlap, but it doesn't have to be like overkill of, folks needing to hear everything about all of the details of the development, unless they're very interested. So that's one idea. And then I guess the other kind of way that one could do it with this computing time, which is, I think, kind of a nicely decentralized way, is that you could have these working groups be the ones that sort of control these resources. And so they could just be like, essentially, if you do polar climate with CANISM, then this working group has this many resources, and then you just kind of allocate within that sort of context of, allocating for science, and maybe some of those resources are also for development or open source development or whatever. So, I mean, that's kind of one sort of fun, very decentralized way to do it. That's how we do it. I often feel like Santa Claus, because I have like these, I don't know, we get like 26 million core hours per working group per year, and I get to like give these out, which is awesome. And I know it might not be quite as big, what we have available. So at 26. Okay. But regardless though, it's still fun. It's awesome. It's like such a great way to build community.
Yeah.
No,
the allocation we have, just to be clear, is about 100. It's 100 cores, so 100 core years. So about 2 or 3 nodes roughly on Niagara and Cedar. But the thing is, this is what Neil didn't mention in his defense of why CANISM is that it's a very economical model.
Yeah, right. You can run a lot. So yeah,
you can do a lot.
Assign some Santa Claus people. The Santa Clauses should just give out these hours for cool work that's being done. Like that's just, and this is the thing, especially like wherever you are, like computing resources are always an issue. You're like, oh, I have these good ideas. And like, I have to wait for the next, like Compute Canada cycle to apply for them. So just, have these and just give them out and let people go to town. That's my, I don't know. That's what I would do. That's what I advocate for.
That's why the RPP, why this is the ideal use for RPP type resources, is that it's not just the resource for research groups is really it's PI specific. RPP is supposed to be a bit broader, and if we could fully use those all the time, that would be great. And so yes, I fully agree. Sorry to jump in, but I'm too excited to hold back. So, yeah.
And so, I mean, I think we can say that we do have those resources and we have some others too. And so, you know, if people have a science project that they want to do, then yeah, just feel free to reach out to us and we'll either set you up with the resources or look at what the best way to do the simulations is. So I am conscious of the time. I think that was a really good discussion and nice and dynamic. So thanks very much to all the panelists. And thanks to everyone for joining. And I think I'm going to hand it back to Paul and Daniela for the closeout.
Thanks very much, Neil and everyone. And thanks for tolerating my jumping in all the time as well. It's been an excellent 2 days. We have a lot of material to digest. I really like to thank Daniela for her for running the show, getting us all organized and helping with the project management and communication. All the speakers for their great contributions and talks yesterday. The panelists today coming prepared to say, you know, really interesting things and keep on point, and a lot of really good questions. So I couldn't be happier with how overall attendance was great. I think we had 40 plus people online yesterday, another 30 today. You know, Friday afternoon for many of us. It's very nice to see you all here. And I just wanted to mention, Daniela, we have a CP4C working group meeting. This is the group that I mentioned yesterday. When's our next meeting? Is it? It's not next week, right? It's
May 2nd.
May 2nd, yeah. So that's May 2nd at noon, and we'll debrief from this workshop. We've got our rapporteurs. So Daniela has been taking notes, as well as Haruki and Jack and Alexandra. So we have some material to digest there. And yeah, Daniela, why don't you talk about, you might mention, like, I guess we have to post the materials from this, but that will probably be on the ARCU website, I guess. So when do you think we'll be able to get that ready? Next week or something?
Yes. I'm just collecting the presentations, and then we will maybe reconvene with Haruki, Alexander, and Jack, just to produce the notes, and maybe end of next week will be ready to be posted.
That's great. Good. Thanks very much. So that's all I have to say. Anything else, Daniela, that you wish to add?
Not from my end.
Okay.
Very happy to be here.
Good. Thanks, everyone. And so I wish you a great weekend. If it's looking sunny out here, so I hope you're having a nice time wherever you find yourself. And we'll be in touch. And please keep in touch.
Thank you, everyone.
Great. Thanks, everyone. See ya.
All right.